Hi, second year students, it's math with AUB. The remaining questions of exercise 4.4 from 4 to 6. Without wasting time, let's embark upon our journey. Most of the question number 4 reads as most of the radioactive substances disintegrate at the rate proportional to the amount present. If the amount of a radioactive substance is 50 gram and its half life is 100 years, find the amount of the substance remains after 400 years, or here it is written that present after 800 years. We have given a radioactive substance and it is open secret that they disintegrate having half life. They have different half lives. In that case, radioactive substance have half life of 1000 years. 1000 years. We have given 50 grams. After 1000 years, it is definitely 25 gram remains. Okay. Now we are asked to find the amount of the substance left after 800 years. Same tiny differentiation, tiny derivative differential calculus comes into play. Amount present changes disintegrate with respect to the amount present. With respect to time, rate of change in the amount with respect to time is proportional to the amount present. Is the amount present. I have explained to you several times within your vicinity, within your domain. You have done this when the force is applied, acceleration produces. Here comes into play the constant F is equal to ma after removing this proportional sign. In the same token, we have to remove this proportional sign and introduce a constant. Normally, we are taking it k, k times e. Okay. In the case of disintegration, in that case, k is less than 0. If something increases, k is greater than 0. If k is 0, it has no change. If k is 0, it has no change. If disintegrate means decay decreases. We must have k is equal to 0. These are all latter matters. Let's solve this differential equation. It is a simple differential equation of first order. Separate the variables. dA over a is equal to k times dt. Integrate with respect to their independent variables. dA over a, k is a constant, dt. It is the famous case of Allen. We have done several times. It is 1 dt means t, a constant c. A constant c. You can start calculation from here or get rid of Allen. It's okay. It's okay. We are getting rid of this Allen by introducing E as a base. E ln A, t raised kt plus c. Ln x and e raised x are inverses of each other. They are inverses of each other. Okay. ELN cancelled out. We have A is equal to e raised kt. A tiny exponential property comes into play. It can be written as e power c as x raised m plus n can be written as x times n times x raised n. Okay, it's a pure constant. Let me write instead of e raised c a c1, another constant. A is equal to e raised kt c1, e raised kt c1. Now, applying the given initial conditions, we have to determine the value of c1 and k. We have determined c1 and k. We put here, and whatever we are asked to do, we can finally attempt this. Now we are interested in the value of k and c1, k and c1, k and c1. How to find out them? Let's see and find out. Let me make a space for myself. Okay, we have A is equal to C1 times e raised kt. Okay. Initially, we have given 50 grams. 50 grams. Initially means at the start, at the commencement of the experiment. T is equal to 0. Utilize both of these, 50 grams. We have C1 e raised k times 0. So, C1 e raised 0 is k times 0 is 0, it is equal to 0. E raised 0 is equal to 1. But mark my words, 0 power 0 is not equal to 1. E is exponential 2.71828, famous irrational Euler number. It's equal to 1. So value of C1 is 50. Value of C1 is 50. We have utilized the condition that at the start of the experiment we have given 50 grams of the radioactive substances at the start. Time is 0. Time is 0. Okay. We have second condition. It has half-life of 100 years, 1000 years. Half-life of 1000 years. So T is 1000 years. T is 1000 years. Half-life. Half-life. Half-life means 50 grams will become 25 grams after first half-life. After first half-life. Utilize this condition. Now plug in the value of C1 here. It is Ra is equal to 50 times e raised kt. Now switch over to this. After 1000 year, our radioactive substance decays, disintegrates, and 25 grams there because it has half-life of 1000 years. 25, 50, e raised k times 1000, 1000. Shift 25 here, 50 here, sorry. 25 divided by 50, we have e raised 1000 times k. So we have 0.5. 0.5 is equal to e power 1000 k. Okay, we are interested k. It is lurking, looming in the power, in the exponent. Taking ln as a base to get to it, ln 0.5 is equal to ln e raised to 1000 k. 1000. We are familiar with from the property of log. Power become coefficient, and ln 0.5 is 0.693, negative 0.693 is equal to 1000 k ln. ln is equal to 1 divided by 1000. Same figure dividing by 1000. We have negative 0.00006.93 is the value of k. Is the value of k. I have divided as well. Let me clarify this step. I have shifted this 1000 here. Let me write again 0.693 divided by 1000. It's our value. Deviate with any figure having 1 with zeros, it's really easy, cool. Shift these points towards left. Introduce 3 zeros here. Means we have minus 0.00006.93 is equal to k. That's the value of k. Look at this. In that case, k is negative. Shows that disintegration or decay or decrease. K is less than 0. Now we have value of C as well as value of k. I have A C1 raised e power kt. A or C1 at the start we have given 50 grams. 50 e raised k, value of k is negative 0.006, sorry, 0.00693. What we have done here, it suits here. What is in that case? I have to shift 0 in that direction. Here it is the case. Here it suits. 0. Okay, dividing by 1000, it travels towards left. Okay, 0.00693. Now we are cool here. It's T. Now we are asked to find what is the amount left after 800 years. Amount left after 800 years. Yes, we are interested in the amount left after 800 years. So instead of T, just plug in 800 minus 0.00. I think there are 000. Okay, 0.00693 times 800 Calculator. 0.00693 multiplied by 800. It will become 50 raised e, I think it's negative 0.55544. Now ln, sorry, e raised negative power 0.5544. We have 50 times 0.5744. Okay, enough digits. Multiply by 50. Multiply by 50. We have amount left is 28.72 grams. Amount left after 800 years is 28.72 grams of the radioactive substance. It's our answer. It's our answer. What do we have? Let me restate the steps for you. Taking a rate of change of the amount present is directly is proportional to the amount present, not directly, amount present. Introduce any constant, dA over dt is k times A. Solving, we have ln A k times T plus C. Leave here, start calculation taking E as a base. We have A is equal to C1 times AKT. Initially, we have 50 grams. When T is equal to 0, we have determined the value of C1 as 50. Then it has half-life of 1000 years. Amount left 25 grams after 1000 years. After 1000, utilizing this condition, we have the value of K, that is, I think, negative 0.0006931. It is. Putting both these values here, and we are asked finally find the amount present after 800 years. It is 28.72 grams left after 800 years. Cool. Moving towards next question. Having thermometer and temperature, you are familiar up to apply Newton's law of cooling. Newton's law of cooling, a cool concept in maths, application of maths. A thermometer, look at this. Capital T stands for temperature and small t the time. Small t the time. Rate of change of temperature with respect to time is directly proportional to the difference of the temperature. Difference of the temperature where T naught is the initial temperature, initial or ground state temperature. I used to call it or room temperature. Room temperature. According to this, we have to compare ground state temperature with every changing temperature. It remains fixed. It remains fixed throughout the experiment. It remains fixed throughout the experiment. So take it a base temperature, room temperature, initial temperature, or ground state temperature. Okay. To get rid of this proportional symbol, introduce a constant. dt over dt is k times T minus T naught, separating variables in order to solve this differential equation. We have done it several times. K times dt. Okay. ln, sorry, integrating with respect to independent variables, dt over T minus T naught. Here K times dt. T naught is a constant. T naught is a constant. T is, however, capital T is variable. Function derivative having overall power 1, it is situation of ln. I have told you several times. Ln T minus T naught is equal to Kt plus C. Okay. Leave here or calculate or introducing E to get rid of this one. I am calculating from here with not induction of E. It's also correct. It's also correct. Let's see and find out. Okay. A thermometer showing room temperature 80 degree Fahrenheit is placed on a block of ice with the temperature of 30. Initially, we have temperature of the block is 80. We are temperature of a thermometer is 80 and our room temperature on a block. Temperature of the block is our ground state temperature. Block's temperature is RT naught in that case. It remains same throughout. RT naught is 30. Is initially means when time is 0. So we have started the calculation means T is equal to 0 plus C. ln 80 minus 30, we have ln 50 is equal to C. Okay. What is value of ln 50? Let's see and find out. ln 50. It is 3.912. Its value of C. Okay, introducing value of C here. Introducing value of C here, and try to manage the value of K. ln T minus T naught. We have K times T plus C means 3.912. 3.91. Okay. Moving further, we have further condition that after 1 minute, the temperature of the thermometer is 40 degree. We are placing on a block of ice. Our block of ice is our room temperature, our ground state temperature. We have to compare every temperature with it. It's 30 degree Fahrenheit. Now after 1 minute, we have something. Okay. After 1 minute, our temperature is 40 degree Fahrenheit. Okay, let me write the equation again. ln T minus T naught is equal to Kt plus 3.912. ln T is 40. However, the ground state temperature is 30. Temperature of the block, temperature of the ice block, it's our base temperature, that's 30 degree Fahrenheit throughout. 40 minus 30 is equal to Kt. After 1 minute, after 1 minute, after 1 minute I have mentioned here, T is equal to 1 plus 3.912. Okay, we are left with ln 10 K plus 3.912. Okay, ln 10 that is 2.3025 is equal to K plus 3.912. Shift this quantity towards the left, make it negative. 2.3025 minus 3.912 is the value of K. What is minus 3.912? We are left with negative 1.6094. That's the value of K. Now we have determined both the constants C as well as K. C are C1 and K. Put value of K also here. So we are finally in a position to attempt this question whatever it is asked. ln T minus T naught, our K is negative 1.6094 times T plus 3.912. Now finally we are asked how long will it take? How long will it take? How long will it take? We are interested in T. To get the temperature to the 70 degree Fahrenheit. T naught is our throughout 30, it will become 70 now. When will the temperature raise to 70 degree Fahrenheit? ln 70, our base temperature of the block is 30 minus 1.6094 T plus 3.912. Okay, 70 minus 30, it is ln 40 is equal to negative 1.6094 T plus 3.912 ln 40. ln 40. It is our 3.6887. Shift this 3.912 here from right to left, it will become negative. Is equal to negative 1.6094 times T. 94 times T. Be within the frame. Try to manage the space for myself. I am trying to manage to give you good view. It's calculation manual. Minus 3.912. It's equal to negative 0.22312 is equal to negative 1.6094 T. That negative cancelled out. Solve for T. 0.22312 divided by 1.6094 is equal to 2. Dividing by 1.6094 1.6094. 1.6094. It's 0.1386. It is. These are the minutes. 0.13 minutes. 0.13 minutes are required for the temperature to be 70 in that case. So our answer is 0.1386 minutes, because unit we have given its minutes. T is 0.1386 minutes in that case. It's our answer. It's our answer in that case. It's our answer in that case. R1 can round off. It will become 0.1. To 2 digits, it will become 0.1. But it's okay. Leave here. Or you can round off according to the given demand. 0.14. Rounding off after 2 digits, 3 digits, 4 digits, 5, whatever has been told you, do according to this. Moving towards final question. However, it is the last question of 4th chapter, but it is the opening or gateway towards 5th chapter. 5th chapter is mostly based on such type of questions. 5th chapter is based on mostly such type of questions. Okay. Now let me read this question. A ball is thrown vertically upwards with a velocity of 40 meter per second. Velocity with which a ball is thrown vertically upwards is 40 meter per second. Develop a differential equation representing the flow phenomenon and find the velocity of the ball after 1 second. Find the maximum height attained by the ball. Neglect the air resistance. Okay, find a differential equation. We are familiar that V means how we can, if we integrate acceleration with respect to time, if we integrate acceleration with respect to time, we get velocity. We get velocity. How? Look, we have S. S stands for distance. ds upon dt, it is known as our velocity, denoted by V. If we differentiate velocity, dv upon dt, or some writers write second derivative of the displacement with respect to time, it's our acceleration. It's our acceleration. Okay, and denoted by E. If we integrate A, we will get V. Differentiate distance with respect to time, it's our velocity. Second derivative is known as acceleration. We have to retract, going backwards. If we integrate acceleration, we get velocity. If we integrate velocity, we will get distance. Keeping this thing in mind, then we are in a position to correct these questions. A wonderful application of mathematics, owing to the Newton, who said that I am sitting on the shoulders of a joint to attempt all these things. Shoulders of the joint. That joint is calculus. Okay, that's in that case we are throwing something upward. Gravity comes to play. Our acceleration is equal to gravity. Going upwards, our gravity is negative. So we have V is negative g times dt. V is fixed, constant. Let me write here. dt integrate, it is going to be minus gt plus c. It's our equation. Now we have thrown the stone. I think it's stone. Yes, a ball with 40 meter per second. Velocity is 40 meter per second. Initially means when at the start of the experiment means t is equal to 0 plus c. So we have 40 is equal to c. Our equation is going to be something. V is equal to minus gt plus 40. It is our required velocity. It is negative gravity times plus 40. Now we are asked to find the velocity after 1 second. Velocity after 1 second. Velocity after 1 second means plug in 1 second. T is equal to 1. Plug in T is equal to 1. We get G is G times 1 plus 40. Write G 10 meter per second square, or 9.8, it's up to you. Both are workable. In that case, we have it is 30.2 meter per second. So our velocity after 1 second, our velocity after 1 second is 30.2 meter per second, 30.2 meter per second. And find the maximum height attained by the ball. Maximum height comes into play from here. Again we have to integrate. Acceleration we have integrated. We have arrived at velocity. Again integrate velocity. We will get the displacement. Okay, let's see how. Mine that there by this equation mine works. It is mine velocity, that's my gt plus 40. Don't you worry about that, just follow Newton law. Velocity means rate of change of displacement with respect to time minus gt plus 4. We are cool with it. Okay, now integrate with respect to t. Again, ts upon dt times dt is equal to negative gt plus 40 times dt. Here integration of velocity is simple distance, that is minus dt square over 2 plus 40t plus c, 40t plus c. It is our displacement, sorry, it is our displacement, or you can say height. Okay, after 1 second it would happen what? S is equal to minus gt square over 2 plus 40 degrees centigrade. Now we are asked maximum height. For maximum height, we have thrown a ball from here. It stays some here. When it reaches the maximum height, at this instant, velocity is zero. When it reaches the maximum height, at this instance, velocity is zero. Plug in the value of velocity 0, get the value of t, it will give us the maximum height. When velocity is 0, find t. When velocity is 0, find t. We have this velocity. Plug in, its velocity is 0 when ball reaches maximum height. Max height. At this instance, velocity is 0. Velocity 0 means minus with gt plus 40 is equal to 0, or minus gt is equal to minus 40. Minus cancel, t is 40 divided by g, or 40 divided by 9.8. 40 divided by 9.8. I am taking gravity 9.8. 40 divided by 9.8. It is, time is 4.0816. Means almost in 4 seconds. It reaches maximum height. Put value of g here, put value of t here, ignoring the constant. We have maximum height. In that case, s is equal to minus g, that's 9.8, t is 4.0816 square divided by 2 plus 40 times t means 4.0816, ignoring the constant because we haven't given the condition to determine the value of that c. Here after 1 second, so when time is 4.0816, the ball reaches max height. Now calculate the max height. We have minus gt square half plus 40 times t plus c. Ignoring the constant c, as air resistance is neglected, we have given no further condition to determine the value of c. Let's put t to get the maximum height, or distance, you can say. Negative g means 9.8, t is 4.0816 square divided by 2 plus 40 times 4.0816, ignoring c. We have 9.8 times 4.0816 having square is equal, that is negative 163.2626 divided by 2, and it is 40 times 4.0816. It is also 163.264. This quantity dividing by 2, we have 163.2626 divided by 2. We have minus 81.6313 plus 163.264. Now minus 81.6313 is equal to 81.6313. That is the maximum height reached by the ball. That is the maximum height reached by the ball. Here, what we have done, it's a simple phenomena. Only two derivatives have name. First derivative of the displacement is velocity. Second is acceleration. What we have utilized in this question, we how to get to be integrate acceleration with respect time. Integrate acceleration with respect time to get to velocity. We in that case, if a body is thrown upward, gravity comes into play. A is equal to g. Going upward, g is negative, so we have minus g dt. Negative g, integration of dt is only t minus gt plus c. Now gt plus c. Okay. Now at the start, gravity of velocity is 40 meter per second. Initially at the outset, t is equal to 0. We have velocity is equal to 40 minus g times 0 plus c. So our constant is minus 40. In that case. So our equation is looks like minus gt plus 40. Okay. C is 40, only 40, not minus 40. It is cancelled, C is our 40. Okay. Again, velocity, integrate velocity to get displacement. Integrate velocity to get displacement with respect to time, minus gt plus 40 times dt. It is differentiation of integration of velocity is displacement, that is our gt square plus t plus 40t plus c. As we have asked, neglect the air resistance, there is no more constant. In that case, we have s is equal to minus gt square over 2 plus 40t pure. It is the case. Okay. And furthermore, when it reaches maximum height, at this very moment, velocity is zero. Here we have velocity is 0 means minus g means 9.8 t plus 40 is equal to 0. Solve 40 minus 9.8 is equal to minus 40. Cancel out, RT is 40 divided by 9.8. RT is something 4.0816 that we have calculated. We have done this just nothing. It is the gateway to chapter number 5. Because all questions based on acceleration, velocity, displacement, and so on. It's my tiny effort for you guys. It's all by itself next.